Today, on how it's made. Leather briefcases. Crop dusters. Corn whiskey. And drag racing clutches. Briefcases come in many styles today. The classic type is a rigid rectangular box made up of two hinged sections that close together. It's often referred to as an attaché case because it was traditionally the type of briefcase used in diplomatic circles by cultural or military attachés. These luxury attachés are entirely handcrafted, made from English bridle leather, a fine leather traditionally used for horse saddles. The cutter lays out patterns for the various parts, then trims around them. Leather, being an animal hide, naturally has scars and blemishes here and there, so he's careful to select blemish-free areas for use as the main surfaces. Next, he uses a punch press to cut out what are called foundation boards, which will reinforce the leather. At this point, an expert leather craftsman takes over. He positions each foundation board on the leather. Using a tool called a bone folder, he marks where the leather will fold over each board. Then he coats the boards with leather bonding glue and positions them along the fold lines he marked. With a tool called a sleeker, he pushes out air pockets and excess glue. This ensures a thorough, wrinkle-free bond. Next, with a tool called a stitch marker, he perforates the edges of the leather. This ensures the stitching will be straight and evenly spaced. It also sets the angle of the stitches, essential for both aesthetics and durability. Now he bevels the leather. This leaves what's known as a raw edge, which he then colors and seals with a reddish stain that highlights the tan-colored leather. The attaché case frame is made of steel. The craftsman uses contact adhesive to mate the frame to the foundation board and leather. Now he can sew the leather. He inserts an awl in each stitch hole to clear a path through the leather and boards. Then he passes two strong saddle stitching needles in opposite directions, pulling pure linen threads waxed with tallow. Next, he rivets in place two traditional-style locks made of hand-polished brass. Then he constructs the handle by sewing several layers of leather around a piece of steel. The handle has a raised rib on the top and bottom. These risers, as they're called, make the handle comfortable to hold. He uses the bone folder to fit a piece of finishing leather snugly against the risers. He glues finishing leather around the handle ends, feeds each end through a brass ring, then folds over the ends to lock in the rings. Then he wraps the rest of the leather under and hand stitches all around. The rings attach to brass handle plates, which he secures from the inside with washers and bolts. Next, he glues in the lid pocket assembly, an all-leather organizer that contains pen loops and pockets for files and business cards. Finally, he lines the bottom section with sheepskin leather that's been coated with a semi-gloss glaze, so it can be wiped clean with a damp cloth. The outer leather is strong and weather-resistant because it's been tanned with natural plant and tree extracts, then conditioned by hand with fish oils and lanolin, centuries-old techniques they still use to make luxury leather goods today. Crop dusters are airplanes specially outfitted for aerial spraying. Farmers use them to seed fields and apply pesticides and fertilizer. The aquaculture industry uses them to feed fish. And emergency crews fly them to spread retardant on forest fires and dispersants on oil spills. Depending on its size, a crop duster can carry up to 2,700 liters of liquid or dry material. The plane is designed to be able to swoop down low to accurately cover the target spray area. At the factory, they manually weld lightweight aircraft-grade steel tubes to construct the frame of the fuselage. Next, they use spring-loaded fasteners to affix aluminum panels to the sides. An anti-rust coating turns the aluminum gold in color. All the plane's aluminum parts require this coating because many of the chemicals crop dusters carry are corrosive. The tank which holds those chemicals is called a hopper. The factory molds it out of many layers of fiberglass, which is deliberately transparent. This enables the pilot to see at a glance roughly how much chemical remains. Inside each of the plane's wings is a row of vertical supports called webs. To make each web, they lay a soft aluminum sheet on a mold, place a rubber mat on top, then load the assembly into a press. A built-in water bag distributes the pressure evenly. This helps form the aluminum sheet perfectly. Next, they soak the web for half an hour in molten sodium chloride at 490 degrees Celsius. Then they immediately submerge the web in lukewarm water. This triggers a molecular reaction that hardens the aluminum. Each wing contains 32 webs. Technicians line them up in an assembly fixture in between the wing's horizontal beams called spars. Once they've riveted the webs to the spars, they cover the structure with aluminum panels, using spring clamps for now. The panels have holes in them to allow regular inspections of the structure inside. After riveting the panels, technicians screw covers onto the inspection holes. They also seal the seams between panels with liquid rubber so chemicals can't penetrate. Next, they install the engine and the propeller, which ranges from 750 to 1,400 horsepower. The prop has from 3 to 5 aluminum blades. Now, the equipment that releases the chemicals from the air. For spraying liquids, they hook up horizontal pipes lined with spray nozzles, called booms. To apply dry chemicals or disperse seed, the flight crew detaches the booms and installs a large stainless steel funnel, called a spreader, under the plane's belly. At release time, the pilot opens a door at the bottom of the hopper, enabling the wind to draw out the contents through the spreader. To spray liquids, a wind-driven pump moves the hopper's contents to the booms. Technicians now assemble and install the instrumentation panel. To fill the hopper with liquid chemicals, they connect a pump to a valve on the side of the crop duster. For dry chemicals, they just lift the hopper's lid and fill her up. More than 3 centuries ago, American bootleggers made corn whiskey by moonlight to avoid being detected by the tax authorities, and so this whiskey became known as moonshine. Today, that whiskey has emerged from the shadows of history and is produced legally, but people still call it moonshine. It was the nectar of outlaws, clear, fresh corn whiskey that's 50% alcohol, and centuries later, it still has a potent appeal. In Virginia, they still make this whiskey the traditional way, allowing corn to germinate in a process called malting. They mix a small amount of the malted kernels with regular corn in a big tank, then funnel the mix into a mill. Inside this mill, automated hammers grind the mix to a cornmeal consistency. This frees some of the starch and exposes it to enzymes from the malted kernels. Those enzymes convert the starch to sugar. They'll use some of this ground corn to make a big batch of yeast. They add it to water in a tank and boil it until it becomes a thick soup. Once it reaches the desired consistency, they allow it to cool to room temperature. They add yeast and blow air into the mix to help the yeast grow, making this one big batch of liquid yeast. In another tank, a ton of corn is being blended with water and boiled. This breaks down more of the starch, converting it to sugar. Once cooled, they pump the mix and the liquefied yeast into the fermentation tank. Over a period of 4 days, the yeast turns the sugar to alcohol. The process also generates carbon dioxide, which is vented into the atmosphere. Every so often, the brewmaster scoops up some liquid and scrutinizes it. If it looks too thick, the conversion of sugar to alcohol is not yet complete. But when the viscosity is just right, they pump the batch into a big copper still. It's just like the type used to make moonshine in the backwoods centuries ago. They heat it to 82 degrees Celsius. At that temperature, alcohol will boil, but water will not. As the alcohol boils off the mix, it's recovered through a condenser. The recovered liquid is 80% alcohol. Talk about a stiff drink. So they add water to cut it down to about 50%, and then it's ready to bottle. To make a darker whiskey, they steep it with what looks like a big tea bag. It's actually wood chips wrapped in cheesecloth. The whiskey absorbs flavor and color from the wood over a period of about 2 months. When the whiskey takes on a golden hue, they transfer it into oak barrels. They allow the whiskey to age for 2 years in a hot room. The heat causes the whiskey to expand, causing it to absorb the flavor of the wood. But the pressure can also cause cracks in the barrels, so the brewmaster routinely checks for leaks. After the whiskey has aged, they adjust the alcohol content by adding a little water. The water is always softened and filtered to remove minerals that could affect the whiskey's taste. At the bottling station, machinery pumps the whiskey into the containers. There's no spillage, and not a drop goes to waste. Machinery then twists on the caps for an airtight seal that preserves the aroma and flavor of this old-fashioned corn whiskey. At the next station, robotic arms grab labels, apply glue to them, then press them onto the bottles. It has taken a combination of down-home methodology and modern technology to prepare this old-fashioned American whiskey for market. And whether it's aged or fresh, this historic whiskey is sure to set the taste buds ablaze. This clutch is not for the family sedan. It's a racing clutch, designed for a car with an 1800 horsepower engine. Without this kind of heavy-duty clutch, there would be no way to transfer that much power to the wheels, and the race car would be going nowhere fast. Race cars use a manual transmission to transfer power to the wheels, so a good clutch is behind every win. Production starts with the flywheel, which connects the clutch to the engine. Computerized cutting tools shape this aluminum part, then move on to carve the cover plate for the clutch. They trim its perimeter to give it the correct profile and reduce its weight. Next, they use a bolt with an industrial diamond tip to level the surface of an iron friction disc. This will allow for better contact with other parts of the clutch. There are typically 2 to 3 of these friction discs in a racing clutch. The clutch discs will ride against this steel insert, which they position on the flywheel. The technician applies locking compound to bolts, then uses them to attach the insert to the flywheel. Here, the technician sets the bolts to a precise torque. Next, he uses this grinder to flatten the surface of the steel insert, again for better contact with the clutch disc. These bolts will anchor the clutch assembly to the flywheel. They're called stand bolts, and there are 6. 1 Here, they sculpt titanium cylinders to act as stands for the bolts that were just installed in the flywheel. Titanium is strong and lightweight, which is important because of the huge amount of energy the clutch must transfer. The technician places a stand over each bolt, then arranges the clutch discs and a floater plate on the flywheel. He presets the height of the stands. Then he prepares the pressure plate assembly. He presses aluminum cups into holes in the cover. These cups will hold springs that will be used to change the pressure of the clutch pack. But he holds off on inserting the springs in the cups. First, he installs a series of levers on the cover plate. He slides pivot pins into each lever. These pins will enable the levers to compress and decompress the clutch pack. He applies lubricant to adjuster screws for the clutch springs, then threads each one into an aluminum casing. He inserts an assembly in each cup, followed by a heavy-duty spring. He now installs the pressure ring on the underside of the cover. When the driver releases the clutch pedal, the levers cause the pressure ring to compress the clutch pack. That action transfers power from the engine to the transmission. He now slips the pressure ring assembly over the stand bolts and secures it with nuts. He adjusts each stand with a socket wrench, then checks the height. He measures the tips of the levers to confirm that they're even and makes any necessary adjustments. He pushes the levers to test this clutch, and the pressure ring responds as it should, creating the necessary pressure on the clutch pack. Finally, a certification sticker and some strapping to secure it for shipping. At the track, this clutch will be serviced between every run. And if it's operating at peak performance, a win could be just down the road.